Hello everyone and welcome to Who Created It and How. Today we're diving into a topic that powers our entire modern world, electricity. But have you ever stopped to wonder who actually discovered it? If you're thinking of one single person, like Benjamin Franklin flying a kite, you're only seeing a tiny spark in a much larger story. The truth is, our understanding of electricity wasn't a single eureka moment, but a long, collaborative journey spanning centuries, involving brilliant minds from all over the globe. So let's travel back in time and uncover the real story of who discovered electricity. Our journey begins way before light bulbs and power grids in ancient Greece around 600 BC. The Greeks, particularly a philosopher named Thales of Miletus, noticed something peculiar. When they rubbed amber, which is fossilized tree resin, against a piece of fur, it suddenly gained a strange ability. It could attract light objects like feathers, dust, and bits of straw. The Greek word for amber is electron, and that's where we get our modern words electron and electricity. Thales and his contemporaries didn't understand what this force was. They thought it was a unique property of amber, perhaps some kind of life force or soul within the stone. They documented this phenomenon, but for nearly 2,000 years, this static electricity remained little more than a curious parlor trick, a mysterious property of a single substance. The world wasn't ready to unlock its secrets just yet. Fast forward to the 16th and 17th centuries, during the scientific revolution. A new spirit of inquiry and experimentation was sweeping across Europe. An English physician to Queen Elizabeth I named William Gilbert decided to investigate this amber effect more systematically. In the year 1600, he published a groundbreaking book, De Magnete, which means on the magnet. While its main focus was magnetism, Gilbert also dedicated a significant portion to what he called the electric force. He was the first person to use the Latin term electricus to describe the property that amber exhibits. Gilbert discovered that it wasn't just amber. Many other substances, like diamonds, glass, and sulfur, could also be electrified through rubbing. He showed that this was a distinct phenomenon from magnetism. For example, a magnet only attracts iron, but an electrified object could attract all sorts of light materials. Gilbert's work was crucial because he shifted the study of electricity from mere observation to rigorous scientific experimentation. He laid the foundation for others to build upon, proving that this was a widespread natural force, not just a quirk of amber. The 18th century is when things really started to get charged up. Scientists began creating machines to generate static electricity in larger quantities. One of the most notable was the friction machine, developed by Otto von Guericke, which used a spinning sulfur globe rubbed by hand to create powerful static charges. These machines allowed for more dramatic and detailed experiments. It was during this time that scientists like Stephen Gray in England made a monumental discovery. Electricity could travel. He found that the electric charge could be transferred from one object to another through conductive materials like metal wires and even a wet hemp string over long distances. He also distinguished between conductors, materials that let electricity flow, and insulators, materials that stop it. This was a massive leap forward. Electricity wasn't just a static charge sitting on an object. It was something that could move, something that could be transmitted. The concept of an electric current was beginning to form. Around the same time, a French scientist named Charles-François Dufay discovered that there weren't one, but two types of electricity. He noticed that a piece of electrified glass would repel another piece of electrified glass, but it would attract an electrified piece of amber. He called these vitreous for glass and resinous for amber. He proposed that all objects contained both fluids, and rubbing them simply separated them. This was the world's first theory of electricity, and it was a good one, but it would soon be refined by one of history's most famous names. Enter Benjamin Franklin. Franklin was more than just a founding father of the United States. He was a brilliant and curious scientist. He was fascinated by the work of European scientists and began his own experiments. He disagreed with Dufay's two-fluid theory. Instead, he proposed a single fluid theory. He suggested that electricity was a single, invisible fluid present in all matter. An object with an excess of this fluid was positively charged, and an object with a deficit was negatively charged. This is where we get the terms positive and negative charge that we still use today. According to Franklin, the flow of electricity was simply the movement of this fluid from a place of excess to a place of deficit. Of course, Franklin is most famous for his legendary kite experiment in 1752. He wanted to prove that lightning was a form of electricity. The story goes that he flew a kite during a thunderstorm with a metal key tied to the string. When lightning struck nearby, the electrical charge traveled down the wet kite string to the key, creating a spark when he brought his knuckle close to it. This was an incredibly dangerous experiment. Please do not ever try this at home. But it proved his hypothesis. Lightning was a massive natural electrical discharge. This discovery was not just academic. It led to his practical invention of the lightning rod, which has saved countless buildings from being destroyed by lightning strikes. Franklin's work fundamentally changed our perception of electricity, linking a small spark from amber to the immense power of a thunderstorm. But all the electricity we've talked about so far was static electricity, a sudden buildup and discharge. The next great breakthrough was the creation of a continuous, steady flow of electricity. This came from an unexpected source, the study of biology. In the late 1700s, an Italian physicist named Luigi Galvani was dissecting a frog. He noticed that when he touched the frog's leg with two different metals, the leg would twitch, as if it were alive. Galvani believed he had discovered animal electricity, a life force inherent in living tissue. He thought the electricity was coming from the frog itself. Another Italian scientist, Alessandro Volta, heard about Galvani's experiments and was skeptical. He believed the electricity wasn't coming from the frog, but from the two different metals interacting through the moist medium of the frog's body. To prove his point, he set out to create an artificial source of continuous current without using any animal parts. In 1800, he succeeded. He stacked alternating discs of zinc and copper, separated by pieces of cardboard soaked in salt water. When he connected a wire to the top and bottom of this stack, a steady electric current flowed. He had created the first electric battery, which he called the voltaic pile. This was a complete game changer. For the first time, scientists had a reliable, portable, and continuous source of electricity. The voltaic pile opened the floodgates for a torrent of new discoveries and inventions. The study of electricity was no longer just about sparks and shocks. It was about creating a controlled and useful power source. With a steady current now available, the 19th century became the golden age of electrical discovery. In 1820, Danish physicist Hans Christian Ørsted made a discovery almost by accident during a lecture. He noticed that when he switched on an electric current in a wire, the needle of a nearby magnetic compass deflected. When he turned the current off, the needle went back to its original position. He had discovered a fundamental connection between electricity and magnetism. An electric current creates a magnetic field. This discovery, known as electromagnetism, was revolutionary. It unified two forces of nature that were previously thought to be separate. Inspired by Ørsted's work, scientists across Europe began exploring this new phenomenon. A French physicist named André-Marie Ampère quickly formulated a mathematical law to describe the magnetic force between two electric currents. But it was an English scientist, Michael Faraday, who would take the next giant leap. Faraday, a brilliant experimentalist with incredible intuition, reasoned that if electricity could create magnetism, then magnetism should be able to create electricity. For years he tried to prove it. Finally, in 1831, he succeeded. He discovered that by moving a magnet inside a coil of wire, or by moving the coil over a magnet, he could generate an electric current in the wire. This principle is called electromagnetic induction, and it is the foundation of virtually all electric power generation today. Faraday's discovery led directly to the invention of the electric generator and the electric motor. He had figured out how to convert mechanical motion into electricity and vice versa. The theoretical side of electromagnetism was elegantly tied together by a Scottish physicist named James Clerk Maxwell. In the 1860s, he developed a set of 4 famous equations, now known as Maxwell's equations. These equations provided a complete mathematical description of the behavior of electricity, magnetism, and their interrelationship. They showed that electricity and magnetism were two facets of the same thing, the electromagnetic field. Even more remarkably, Maxwell's equations predicted that these electromagnetic waves should travel at the speed of light, leading him to correctly propose that light itself is an electromagnetic wave. So who discovered electricity? As you can see, there's no single answer. It was a chain of discovery, with each generation of thinkers building on the work of those who came before. It started with Thales of Miletus, noticing the strange properties of amber. William Gilbert turned it into a formal science. Benjamin Franklin tamed lightning and gave us our language of positive and negative charges. Alessandro Volta gave us the battery, a source of continuous current. Ørsted and Faraday unlocked the deep connection between electricity and magnetism, paving the way for generators and motors. And Maxwell provided the complete theoretical framework that describes it all. The story didn't stop there, of course. People like Thomas Edison and Nikola Tesla then took these principles and used them to build the modern world of electric light and power that we live in today. Each one of them, and many others, holds a piece of the answer. It's a beautiful example of how scientific progress is a global, multi-generational human endeavor. Thank you so much for joining us on this journey through the history of electricity. I hope you found it as fascinating as I do. If you enjoyed this video, please give it a thumbs up, and don't forget to subscribe to Who Created It and How for more deep dives into the origins of the world around us. Hit that notification bell so you won't miss our next episode. Thanks for watching and see you next time.